Welcome to the next free video in the Active Directory training course. In the last video, I looked at how to create sites and subnets. In this video, I will look at how these sites can be configured to replicate Active Directory traffic in an efficient way that matches the current state of your network. First of all, I will start with just the New York site. In this particular case, let's say the New York site has 7 domain controllers in it. If the client were to log in to the network, they would be authenticated by one of the domain controllers. If the user then changed their password and logged off and logged on a second time, they would be authenticated by a different domain controller. For this reason, you want replication within a site to happen quickly. This type of replication is called intra-site replication. Intra-site replication is replication that happens between domain controllers in the one site. You will be happy to know that Active Directory handles this kind of replication without any configuration. It does this by connecting all the domain controllers in that site together in a ring. You can see that the 7 domain controllers are each connected to 2 other domain controllers. This gives some redundancy and also reduces the number of connections required in sites with a large number of domain controllers. In Windows Server 2003 and above, intra-site replication will start 15 seconds after a change has been made on a domain controller. With such a small delay, all domain controllers on this network will receive the change in less than a minute. If the number of domain controllers on this network were increased to 8, the delay for a change to replicate to each domain controller starts to increase. Each domain controller will wait 15 seconds before sending replication data to the next domain controller. To reduce the delay, Active Directory will automatically create additional connections between some of the domain controllers when you have 8 or more domain controllers in the one site. This ensures that there are no more than 3 hops between one domain controller in the site and any other domain controller. The extra connections ensure that changes in the site are propagated to each domain controller in less than a minute. All these connections are created automatically in Active Directory inside the site, so you never need to worry about configuring replication inside an individual site. The next part of replication in Active Directory is between sites. This kind of replication is called inter-site replication. In this example, consider the link between New York and Washington. In order for these 2 sites to replicate changes between each other, there must be a site link connecting the 2 sites. This is not created automatically and needs to be created by an administrator. In this example, New York has 7 domain controllers and Washington has 3 domain controllers. In order for replication to occur, Active Directory will automatically pick a domain controller in each site to act as what is called a bridgehead server. The bridgehead server in each site will replicate changes between the sites. When a change is made on a domain controller, it will be replicated to all other domain controllers in that site. When the change reaches the bridgehead server is responsible for replicating that change to the other bridgehead server in the other site. This system is a lot more efficient than individual domain controllers attempting to replicate changes to other sites. Active Directory will automatically choose a domain controller in each site to act as a bridgehead server for you. If that domain controller is shut down or is no longer available, a new domain controller will be chosen. In some cases, you may have a particular domain controller or domain controllers that you want to use as the bridgehead server. Active Directory allows you to select a domain controller or domain controllers to be the bridgehead server for that site. These are called preferred bridgehead servers. Be warned, however, if you choose your own bridgehead servers and these servers are not available, no replication will occur between the 2 sites until one of those preferred bridgehead servers comes back online. Once you have a site link configured, you can configure some options on that site link. The first option allows a schedule to be configured which will determine when replication will occur. In some cases, companies may configure this replication to happen after business hours. The next setting allows a cost to be configured for that site link. The cost is a numerical value that is applied to a site link, telling Active Directory what priority these links should be used. To better understand how costs work, let's now consider what happens when the London office is added to the network. The London office is connected to the New York office by a direct link. In order for replication to occur, a site link is created between London and New York. The link between London and New York is unreliable and at times will go down for hours at a time. For this reason, another link is established between Washington and London. This link is more reliable, but is charged according to how much traffic is transferred over it, and thus the company only wants to use this link when they have to. In this example, the London to New York site link and the New York to Washington site link are given a cost of 40. The site link between Washington and London is given a cost of 100. The cost of transferring data between sites is calculated by adding up the value of the site's links. The route with the lowest cost will be used. In order for data to go from Washington to London, the lowest cost would be via New York. Why? The Washington to New York site link and the New York to London site link add up to a value of 80. This is lower than the cost of the link between Washington and London, which has a value of 100. If the link between London and New York was to go down, then the Washington to London link would now become the link with the lowest cost. Traffic from New York to London would now travel over the Washington to London site link. If the link between New York and London were to come back up, it would be seen once again as the route with the lowest cost, and thus the site link between Washington and London would no longer be used. The last option to consider when creating a site link is which transport the site link will use. The two options for this are RPC over IP and SMTP. RPC over IP is often referred to as just IP and supports everything Active Directory needs. In the real world, you are more than likely only going to use the IP transport for Active Directory as it supports everything. The second transport, SMTP, supports everything except file replication services. At the domain level, file replication is used to replicate the sysvol share containing all the login scripts and group policies. For this reason, you can't have a functional domain infrastructure using just the SMTP transport. Items like the login scripts and group policy would simply not be replicated between domain controllers using only the SMTP transport protocol. Items like Active Directory changes can be replicated using the SMTP transport, as well as changes in the schema. For these reasons, the SMTP transport could be used between different domains in the forest. Using the SMTP transport will not replicate everything at the domain level. The fundamental difference between the SMTP and IP transport is that SMTP transport uses asynchronous communication, whereas IP uses synchronous. Asynchronous communication can send replication information without the need to get a response back. If you had an unreliable network, a large block of SMTP information could be sent over the network without waiting for the other side to confirm that it has received anything. IP, in contrast, uses synchronous communication, which means that it waits for a response each time data is sent. If no response is received, it stops sending data. With network speeds getting better and more reliable, in the real world, I would just use the IP transport for your site links. In the old days, SMTP transport was used mainly for networks that were unreliable or not directly routable using the IP protocol. Nowadays, with the IP protocol being the default protocol used in computing, there is unlikely to be a need to use the SMTP protocol on the vast majority of production networks. Active Directory replication tends to be quite light on the bandwidth, as only changes are replicated, and thus even on slow, unreliable links, I would personally still give the IP transport a go before using the SMTP transport. For your information, the choice of transport only applies to inter-site replication. Domain controllers in the same site are always replicated using the IP transport. The last thing I want to cover before I look at how to configure replication in Windows Server 2008 is the Knowledge Consistency Checker, or KCC. Once you configure your site and site links, the Knowledge Consistency Checker will automatically make connections between the sites for you. If a network goes down between two sites, the KCC will automatically reconfigure the connections between the sites to ensure that Active Directory replication will happen. In our previous example, when the link between New York and London went down, the KCC's job was to create a connection between Washington and London for replication to occur. The KCC does this in the background and does not need to be configured. You can create your own connections in Active Directory as well, but on most networks it is simpler and easier to allow the KCC to perform these steps for you. The KCC also creates the connections that are used for intrasite replication and determines which domain controllers will be used for bridgehead servers. The KCC does this with information from the Active Directory database. If the same copy of the Active Directory database is in multiple locations, the KCC will always come up with the same result. If two different domain controllers have a different copy of the Active Directory database, that is, some changes have not yet replicated, the result the KCC comes up with may be different. What this means is that on a network that is replicating well, all domain controllers, given enough time, will create the same links between sites and their domain controllers. If you are finding that connections are not being made between your domain controllers, check for replication errors in the event viewer and also DNS-related errors. Replication problems can stem from domain controllers having difficulty resolving the IP address of other domain controllers. I will now change to my Windows Server 2008 R2 domain controller to look at how to configure replication. I have already created sites and subnets in the previous video, so all that is left to be done is to create the site links for these sites to replicate over. To do this, I will open Active Directory, Sites and Services from Administrative Tools under the Start menu. To configure the sites links, I will expand down to Inter-Site Transports. There are two transports available under here, IP and SMTP. When I open IP, there is already a default site link called Default Site Link. This is created by default by Active Directory when it is first installed. If you never create any additional site links in Active Directory, all of your sites that you create will be linked to each other using the default site link. When this occurs, the Knowledge Consistency Checker will ensure that all your sites replicate with each other. However, the replication may not be a good match for your network topology. Microsoft recommends that you do not put more than 3 sites in the one site link. First of all, I will rename the default site link to New York to Washington. You are free to rename the default site link or create a new site link and remove the default site link, or simply leave the default site link in Active Directory unused. To match my network topology, I need to create 2 more site links. To do this, I will right-click IP under Inter-Site Transports and select the option New Site Link. This site link I will call New York to London. Once I enter in the name, I need to add the sites that will use this site link. In this case, London and New York. In this case, I will be adding only 2 sites to each site link. However, there is nothing stopping you from adding more. As you will see in a minute, the Knowledge Consistency Checker will determine which connections to create based on which sites are in the site links. Finally, I need to create 1 more site link for my backup link from Washington to London. This is created the same way I created the other site links. Once the site links are created, I need to configure them. First of all, I will open the properties for the New York to London site link. At the bottom, notice the cost value assigned to this link is 100, the default value. I will change this value to 40, so this site link will get preference over the backup site link that I just created. Under this is how often replication will occur over this site link. The default is 180 minutes, or every 3 hours. This setting can be as low as 15 minutes. At the bottom is a button to change the replication schedule. When I press this, I can select the times that Active Directory replication will occur and can also configure it to be disabled at certain times. For example, I could disable replication if I wanted to for Monday through Friday during business hours. Now that I have finished configuring this site link, I will exit out of here and open the properties for the New York to Washington site link. Since this site link was originally the default site link, all 3 sites are in here, so I will remove the London site since it is no longer required in this site link. I will also change the replication cost to 40, so this site link is favored over the backup site link from Washington to London. Now my 3 site links are created. The Washington to London site link I will leave on the default cost of 100. It will only be used if one of the other site links is not available. By default, the Knowledge Consistency Checker will create links that connect sites together that are connected by other sites. For example, since New York is in 2 different site links, the Knowledge Consistency Checker knows that Washington can reach London via New York. The Knowledge Consistency Checker will do this automatically. You can select the option New Site Link Bridges. By default, the site link bridges will be created automatically, and creating a manual bridge will be ignored anyway unless you disable automatic site bridging. When I open the properties of the IP transport, you will notice the tick box to ignore schedules. This is a quick and easy way to override any schedules that have been configured. Under this is a tick box for Bridge All Site Links. If you deselect this, you will need to manually create all the site links bridges between your sites. Unless you have a good reason for doing this, I would leave this option ticked. It is generally easier to allow the Knowledge Consistency Checker to work out the site link bridges from your own site links. If you've configured them correctly, it should make some good choices for these site link bridges. When I right-click on the SMTP transport, you will notice that I have the same options as IP. Given the choice of transports, I would always use the IP transport where possible. But on some networks, you may see the SMTP transport used. Configuring of the SMTP transport is the same as the IP transport. The only difference is the functionality that it supports is different. For this reason, I won't configure any SMTP transports. If I now expand down to NYDC1 and open the properties for the server, on the General tab I can see which transports this server will use. By default, IP and SMTP will both be enabled, so the Knowledge Consistency Checker will create both types of connections where required. In this case, I have not created a transport for SMTP and assigned any sites to it. Until I perform this step, the Knowledge Consistency Checker will not create any SMTP connections. By default, the Knowledge Consistency Checker runs every 15 minutes, so I will pause the video and return later to allow it some time to run. Now that the Knowledge Consistency Checker has had some time to run, I will expand down until I see NTDS Settings, which contains the settings for this server. When I open the properties for the NTDS settings and go to the Connections tab, you will see all the incoming and outgoing connections from this server. All of these are created automatically by the Knowledge Consistency Checker. When I exit out of the properties, you will notice here that I can see a list of all the incoming connections. On the left-hand side, notice that these are automatically generated. These are created by the Knowledge Consistency Checker, and assuming that everything else is configured correctly, that is, your sites, subnets, site links, and transports, these should be created automatically for you. When I right-click NTDS Settings, notice the option New Active Directory Domain Services Connection. Selecting this option allows me to create a manual connection between two domain controllers. Once this connection is created, this will appear with the other connections. On most networks, there should not be a need to create a manual connection, as the Knowledge Consistency Checker will create the required connection automatically. If you do find that a connection is missing and do not want to wait for the Knowledge Consistency Checker to run again, right-click NTDS Settings, select All Tasks, and then select the option Check Replication Topology. This option will force the Knowledge Consistency Checker to run. Windows will give you a confirmation dialog telling you that the Knowledge Consistency Checker was run and you may need to refresh the screen. Looking at the connections, notice that a connection was made to London. This means the Knowledge Consistency Checker has decided to make this server a bridgehead server. If you want to force a replication, right-click the connection and select Replicate Now. You should not need to force a replication to another domain controller in the same site, as the replication should happen very quickly. Notice that forcing a replication will give me a confirmation dialog telling me that the replication was successful. This is a fast way of testing the replication in your Active Directory environment to ensure that it is working correctly. To better understand the connections that the Knowledge Consistency Checker has created, I will show a graphical view of the connections on the screen as I go through them. Next, notice the two connections that have been made to NYDC6 and NYDC7. Remember, the connections shown here are incoming connections originating from the other domain controller. Outgoing connections from this domain controller are not shown here. If I expand down to the next domain controller, two connections have also been automatically created. Expanding into NYDC3 shows another two connections. However, notice that there is now a connection traveling in both directions from NYDC2 to NYDC3. It is important to remember that the direction of the connection does not determine which way replication occurs. The direction only refers to who created the connection. Like the telephone, one party needs to call the other party to create the connection, but once done, both parties are free to talk to the other. Expanding into NYDC4 shows another two connections. Expanding into NYDC5 shows that three connections have been created. One of the connections is to Washington. This domain controller has been selected as a bridgehead server. This goes to show that multiple bridgehead servers can be selected in the same site. The important thing to remember is that only one bridgehead server is responsible for all replication to each remote site. If I expand into the connection for NYDC6 and then NYDC7, notice that this now completes a ring for the connections. Each domain controller has two connections, forming a ring going into each direction. This allows replication to occur inside the one site, even if one domain controller were to fail. Replication to the Washington and London site will go through the one exit point respectively. If a domain controller was to become unavailable for a long enough period, the Knowledge Consistency Checker would delete and add connections as required. The process does take longer than the 15 minutes, as the Knowledge Consistency Checker does not remove connections immediately when it runs. This is done to account for domain controllers being taken offline for a short period of time for maintenance or small network outages. Microsoft also provides a command line tool called Repadmin, which can be used to perform some of the tasks I performed in the GUI. If I open a command prompt and run the command repadmin/kcc, this will force the knowledge consistency checker to run. In this case, it will run only on this domain controller, but if I add the parameter site:"site_name, this will force the knowledge consistency checker to run on all domain controllers in that site. If you want to force a replication to occur, you can run repadmin/syncall. There are other parameters as well with this command, but the last one I will look at is bridgeheads. This will show all domain controllers working as bridgehead servers in your Active Directory environment. Well, that's everything you need to know about sites and Active Directory replication. In the next video, I will look at user accounts in Active Directory. Thanks for watching another free video from IT Free Training. Please consider subscribing to us on YouTube to get notified when we release new videos.